This is the question asked in today's skillrack daily challenge. So in the first line of our input, we are given two integers. The first integer is n and the second integer is x. So first our task is to generate the binary representation of the integer n. So n is equal to 52 and the binary representation of 52 is 110100. So I will also write it over here. So this is the binary representation of 52. So now what we have to do is we have to remove the last bit in each and every iteration. So in the first iteration we have to remove the last bit alone, and in the next iteration we have to remove the last two bits like that. So here I am removing the one bit alone from the end. So after removing one bit, the decimal value of this new binary expression is 26. So I am also writing it over here. And now in the next iteration we have to remove another one bit from end. So I have removed one more bit from the end, and now the decimal value of this new binary expression is 13. So I'm writing here 13, and then again we have to remove one bit from the end. So after removing one bit it becomes 110. So the decimal value of this binary expression is 6. So I'm writing it over here. And then again in the next iteration we have to remove one more bit. So after removing one more bit it becomes 1. So the value is nothing but 3, and again in the next iteration we have to remove the one bit alone. So after removing one bit we will be having only 1. So this is nothing but the decimal value is 1. So these are all the possible decimal values which we are able to form, and now we have to count how much of these are divisible by x. So x is equal to 2. So the first decimal value 52 is divisible by 2, and then 26 is divisible by 2, and then 13 is not divisible, and 6 is divisible by 2. So I am highlighting it, and then 3 is not divisible, 1 is not divisible. So out of 6 decimal values, 3 decimal values are divisible by 2. So in our output we are printing 3 because there are 3 decimal values which are divisible by x. So this is how we have to print the output. So first we have to generate the binary representation of n, and then we have to remove one by one bit from the end, and then we should obtain the decimal value for every binary expansion, and then we have to count whether its decimal is divisible by x. Now let us see how to write a C program for this. So first I am creating two integer variables named n and x, and in the next line using a scanf statement I am accepting the integer n and x as input, and then I am creating an integer array named binary and an integer variable named l, and I am initially setting it to 0. So we will be using this integer variable l for indexing the binary array. So now our task is to find the binary representation of the integer n. So here we have to create a while loop that iterates until n becomes equal to 0, and in every iteration we will be dividing n by 2, and we will be storing n modulo 2 in the binary array at the index l, and after storing the n modulo 2 in l we have to increment the value of l. So we can directly store at the index l++. So finally after the execution of this while loop we would have found the binary representation of the integer n, but the binary representation will be present in reverse order. So accordingly we have written the remaining line of code. So instead of reversing it we have just kept it as such and proceeded with the reversed binary expression. So now we have to count the number of decimals which are divisible by x. So I am creating a counter variable and I am setting it to 0, and then I am creating a loop that iterates from 0 to l. So l is nothing but the number of bits in the binary representation, which is nothing but the length of the binary array. So in every iteration of this while loop I am creating two integer variables named current decimal and power, and I am initially setting both of them to 0. And in every iteration of this I loop what we will be doing is we will be finding the current decimal value after removing the last bit from the binary representation, and we will check whether the current decimal is divisible by x or not. So to find the current decimal value I am creating another j loop. So this j loop iterates from I till l. So here I am creating that j loop that starts from I and iterates till j less than l. And also in every iteration of this j loop I am simultaneously incrementing the power. So power plus plus. So in the first iteration the value of I will be equal to 0. So 0 is nothing but the last bit of the binary representation, because we have stored the binary representation in reverse order. So we haven't changed it. So we are keeping it as such and we are writing the remaining lines of code. So what happens is, when the J loop iterates for the first time, it iterates from the last bit till the first bit. So we will be able to find a new decimal value, and in the next iteration the value of I will be incremented by 1. So now what happens is, we will be starting from the last previous bit and iterating till the first bit. So that is what we actually need. So we have to remove the last bit one by one in every iteration. So in every iteration we will also calculate the decimal value. So while iterating through this array, if the bit is equal to 1, then we will find the value of 2 power the current value of power, and we will add it with the current decimal value. So we have to write a condition like current decimal plus is equal to, we have to call the function POW, and within the arguments we have to give 2 comma power. So finally, after the execution of this loop, we would have found the decimal value of the current binary representation after removing the last bit. So now if the current decimal value mod x is equal to 0, then we will increment the count. So like this we will be doing for all the decimal values, and finally after the execution of the I loop, we would have found the total number of count. So we are printing it. So this is the logic to solve today's daily challenge. Thank you for watching.